Okay, we are going to get radical now because we've got some radical equations to solve. I've chosen D because it's one of the more interesting ones and one of the ones which might throw you off a little bit, so watch and learn here, troopies. Okay, you want to isolate the radical. The trick is, once that's alone by itself, we get rid of the radical by squaring both sides. So it's quite simple. I just add 3 to both sides, and I get that radical isolated. 3x plus 4 then is equal to negative 4. By squaring both sides, right, any radical squared is going to become that interior part. So I get, when I square this side and I square this side, I get 3x plus 4. And that's equal to, well, negative 4 times negative 4 is positive 16. And then I go about solving this. I subtract 4 from both sides. 3x equals 12. I divide both sides by 3, and x equals 4. And that's all well and good, and it's very similar to the sample problem that you've been given in the practice bit. However, with these problems, you always want to check the solution because strange things can happen. If I take and plug that 4 in, it should work out. 4 times 3 is 12. 12 plus 4 is 16. When I square root 16, I get 4. But 4 minus 3 is not negative 7. So this one is no solution. Does not work. Okay, cannot do it. It's this negative sign that when we square it, it becomes positive. That's a little red warning flag. So that's the way you solve them, but when you get your solutions, make sure you check to see if they work. All right? On to part 12, where it says simplify each of the following. This is really a chance to practice your laws of exponents. If I do E, where it's, is this section 13 then? Sorry. No, it is 12. So that was back to 11. And this is 12. Anyway, we have x squared in parentheses to the 3rd power all over x to the 4th. Okay? Well, we have 3 essential laws of exponents, and they're in your packet there, so you can review them. But the top one is simply that this to the 3rd means you take whatever is in the parentheses, you multiply it by itself 3 times. So it's no different than saying x squared times x squared times x squared. Well, x squared is just something times itself, so it's like saying x times x times x times x times x times x. So that's why it's x to the 6th. If you've spent your time memorizing rules, yes, you multiply those and you get 6, but that's sort of like why it breaks down and is what it is, over x to the 4th. Well, that's like having x down there 4 times, and each of these fractions is just 1. X over x is just 1, so we can go through and cancel all these out, and we're left with just those 2, and that's x squared. So that's how you simplify those. Pretty straightforward. Okay. Then in part 13, they've given you more radical problems, and I'm just going to quickly do it this way rather than shut off the camera. I'm tired of walking back and forth. If we do something like x plus 5 to the 2nd power, it's very tempting to want to bring that 2 in and write x squared plus 25. However, that is not the case because you must FOIL these out. So I just want to alert you to that. When you see something squared, like we did in the previous problem, it's that something times itself. X plus 5 times x plus 5. And here's where you FOIL, right? The first terms are x squared. The outside terms here, the O term, is 5x. The inside term, the I term, is also 5x. And then the last term, the L term, is the 25. So it's close to this, but we really need to insert that middle, that's the rainbow part I referred to, 10x. 5x plus 5x is 10x plus 25. So I wish I had $1 for every time somebody saw this and just brought in that square, because I would be rich and retiring and calling you from the Bahamas. But don't make that mistake. All right, okay, I'm back. Little glitch there, but here I am doing, it's the last one, the very last one, this algebra section, part K. When you see a problem that has a lot of different things going on, you've got numbers, you've got variables, we've got negative exponents, just isolate things. Just deal with the numbers separately. That's pretty simple. 12 over 4, that's 3. And then this one right here with the x's, well, x to the third over x to the negative 2, that's just our division rule. And that's going to be x to the 3 minus, because it's division underneath, but then it's a minus 2. So that's x to the 5th. And then here it's y to the minus 4 minus a little invisible 1. So that's y to the minus 5. But generally we do not write negative exponents, so we would write this as 3x to the 5th over y to the 5th. And that's your final answer. So that's it for algebra. We'll do geometry another time. First one, skill set 26, is pretty straightforward. I don't even think I'm going to do these because they are relatively simple. This is simply the triangle sum. You should know that from earlier years. These are vertical angles. Opposite vertical angles are congruent, so you can do the math on that. A straight line is 180 degrees, and then this one is more just about picking up on the symbols. That's the right angle symbol or perpendicular symbol, and those are 90-degree angles, and they've given you one angle. So you can do that pretty straightforward. The next one underneath this, there's skill set 27, and this one is all just about the markings, knowing what the markings are. These little arrows indicate that they're parallel. If these two lines went on forever, they would not touch. They're coplanar. That's the perpendicular sign again. So you're just going to list all of the relationships indicated by those marks. So just picking number 2 for an example, you'd say that AD, and you just write that AD with a line over it. That indicates a segment. And then you could just write it out is parallel to CB or BC. And that would be one of the things. Actually, it's not parallel. These are congruent. I'm sorry. Those little marks there mean they are the same length. These two marks indicate that this pair is also the same length. So this is a parallelogram, but not because of the marks. They are simply congruent. So that is all the relationship you could say based on those marks, unless we'll learn later that we go through a formal proof and establish that it's a parallelogram. But right now, that's all you write. This one, these are parallel, these two, and these opposite pair are parallel because those are the arrows and not the single line. So just, you want to know that. Occasionally people go through a big portion of the year and they've not brushed up on their geometry, okay? Then we get to skill set 28. This is a little bit more difficult. I apologize, it's a little bit hard to see, but if you go to your page and you read through these, it's just all about finding the areas and the surface area and then the volume. Area and surface area, that's a 2-dimensional measurement, but volume is a 3-dimensional measurement. These will all be in square inches in the first two, or square centimeters, whereas 6, 7, 8 will be in cubic centimeters or cubic inches. Just choosing one that's a little bit harder to do. This one, number 5, says a cylinder with a height of 20 centimeters and a base of radius 5. So a cylinder that has a height of 20, so it's 20 high, and then the radius from the center, that's our base, that radius r equals 5. Well, the surface area, if you open up a cylinder like this sheet of paper and lay it flat, you'll see that you have a rectangle with then a circular top and a circular bottom. And the area of these circular top and bottom, that's just going to be pi r squared with r5, and then there are 2 of those. So 25 pi times 2, the surface area of the top and the bottom would be 50 pi. So you can just write that in exact form. You can multiply it by pi, 3.1415, etc. if you want to, but exact terms is okay. A little bit harder is figuring out the area of this rectangle. Well, we know the height of this is 20, so this dimension here is 20, and then the distance around the circles, the top and the bottom circles, is going to be then the diameter times pi. Well, if the radius is 5, the diameter is 10, and this is a distance of 10 pi. So 10 pi times 20 will give you 200 pi. So then you get an answer of 250 pi right there for your surface area of the cylinder. Okay.